Okay, so my name is Abe Taha, and today I'm going to talk to you about toolings and products that Karmosphere builds to make life easy when you're trying to write MapReduce jobs. In the very beginning, I'll start with maybe a very quick background of who I am, and then I'll poll the audience to get to know you a little bit better. Unfortunately, I'm not going to change the presentation depending on the mix in the audience. I'll talk a little bit about who's Karmosphere, what do we build, show maybe a couple of example problems for MapReduce. And some of them would be the very simple ones like word count. Some of them would be precipitation averages, for example. And I'll show the MapReduce implementations of these. And then I'll go to do a demo of an alpha build of our product, just to keep things a little bit more interesting. So if things fail during the demo, please forgive me. And then at the very end, I'll give a summary and then answer any questions. So a little bit about my background. I'm mostly an infrastructure guy. So I worked on search and social search at Yahoo, and then I did similar things at Google, working on apps infrastructure. So if you see any bugs in Yahoo search, which is dead now, or in Google presentations or Word documents, then I had something to do with that. And I got introduced to Hadoop when I started an analytics team at Ning. Ning is a startup that helps people build websites and runs them as businesses. And at that time, we built an analytics team that would get all the user events and start doing maybe a little bit of business analytics, like Will was presenting before. Trends of users, for example, how networks are growing, error rates, and so on. And then we delved a little bit more into machine learning to understand what the users were producing. So we did a lot of text analysis. We did a lot of recommendations, users to users, and networks to networks. And then I worked at Ask on dictionary and reference properties, and very recently joined Karmosphere. All right, so a quick poll. How many of you are developers? Okay. That's good. And how many are business analysts? Okay, that's good. I'm not going to present that product today. So that's, how many are sysadmins? All right, good. Hadoop operators? They're probably the same guy. Okay. Other managers or evangelists? Okay, all right. That's good. So a quick word about Karmosphere. Karmosphere is a startup, and we've been in the Hadoop space for roughly about 9 months. We're very small. We're in Silicon Valley, and we took a look at the Hadoop space. There are infrastructure operators that provide you with easy installs for Hadoop, like Cloudera and maybe IBM and Yahoo distributions. And at the very top of the space, there are the BI vendors, and IBM is one of them, and pt1 is one of them, MicroStrategy as well. So we thought that the niche that we can play in is build tools that would help both developers and analysts make sense of the data on the Hadoop clusters. And the analysts that we're trying to target are not the ones who want to use the BI tools, but the ones maybe who have a little bit of technical background, but don't want to interact with the clusters by writing Java jobs. So something in between. Maybe interact with the cluster using Pig, or interact with the cluster using Hive. So on the development side, which is what I'm going to demo today, we have a couple of products, and they're mostly plugins for Eclipse and NetBeans. These are the IDEs that we support, and they come in 2 flavors. One of them is the Community Edition, which is free, and the other one, which is the Professional Edition, which will cost an arm and a leg, but we actually don't know how much it will cost. It will be on par with other developer tools. And so the Community Edition is focused on the initial phases of MapReduce development. And the idea is to make prototyping a little bit easier. So you have a workflow that would help you visually design your MapReduce jobs, experiment with a couple of classes, put in sample data, and then see how the data how the data is processed locally without a Hadoop distribution on your computer, and would help with debugging if you have any semantic errors, for example, in your code. And you can get the community edition from the 2 sites that are listed here, one for Eclipse and one for NetBeans. And if you get the community edition, I'd wait maybe for a couple of days because we're going to have a new build that would fix some of the issues that people are seeing with these 2 products. But the other product is the professional edition, and includes almost all functionality of the community edition, but focuses a little bit more on what happens after you write your MR job. So you write your MR job, there are no bugs in it, there are no semantic issues. And then you deploy it to the cluster, and then you discover that it runs for a very long time. And clusters cost money, so either if you have your own cluster, if the job doesn't run very fast, then you have to buy newer machines, or if you provision things on maybe on the cloud using Amazon's Elastic MapReduce or other services, then you still have to pay per machine hour. So the professional edition would help you profile your job, see how it works, help you in visualizing your counters, for example, and seeing your log files and errors that happen on the cluster. It also includes facilities for you to package your jobs and deploy them on different types of clusters. So either it's a local cluster, for example, that you've installed in your laptop, or in a colo that you own that is not behind any firewalls, or a colo that you own that is behind maybe a SOX proxy or an SSH tunnel, or an Elastic MapReduce, any of the Amazon services. And all this is seamless to you because we have code that abstracts most of these deployments. And it includes technical support. We don't know what the technical support is until now because we're very small. Most likely it's going to be email, or there could be an 800 number that you call. And the beta is ready, and I'm going to demo a version of it today, and you could sign up by emailing this guy at Karmasphere, so Gerald Luca. And the other tool that we're building that is not ready yet is a SQL-based product that helps analysts make sense of data on Hadoop or on Hive clusters. And so the interface is very similar to Hive-based, but include visualizations like tools like Toad, for example, or SQL Developer, or PL SQL developers that would show you how your query is executing, what's the query plan, whereas most of the time is spent in the queue, and help you optimize the runtime of this query. We're also including PIC support. So same thing, you could have a tool that is very similar to the open source PIC pen that allows you to draw stages maybe of the PIC execution script, and it would generate these for you. So we generate the code for you in this case. And you could sign up for the beta by also registering on our site. Okay, so Steve explained the model behind MapReduce, and so why is MR development a pain in the behind, right? So the first thing is it's the mental model. Now you're thinking in terms of tuples and a couple of functions that operate on these tuples, map and reduce functions. And that mental model comes very naturally to people who have worked with functional languages, older functional languages like Lisp, for example, and maybe newer functional languages. But for people accustomed to working with imperative languages, it's a little bit hard to grasp. And unfortunately, no tool would help you with that. So not even our Studio tool would help you with that. But other abstraction models on top of the MapReduce model will. Something like PIC, for example, or something like Hive would help you with that. And then you want to write a MapReduce job, and you need to set up your project in your favorite tool. So either in Emacs or VI or Eclipse or NetBeans. So you have to import jars and other things. And you start writing a job, and it would check the syntax and maybe give you autocomplete and other things. And then you need to test it. So you need to have a Hadoop setup. Either a local Hadoop setup on your machine. It's relatively easy, but it presents sort of a barrier to entry for people who wanna experiment with Hadoop. Or you set it on a cluster that you have. You still need maybe a sysadmin or someone who would go in and follow the instructions on any of these distributions. And then you run your code, and you're in the phase of rapid prototyping. Most of the maybe initial uses of Hadoop, as Will was mentioning, is to parse log files. So you want to parse log files, and the log files might be something like Apache logs where you could get parsers for, or it might be custom code where we'd have to write parsers for these. So you either end up writing a regular expression, for example, or do a substringing on most of the entries of the log file. And most of the time you get that wrong in the very beginning. And you get that wrong, and it's a semantic error. It's not a syntax error. So you compile your code, it works fine, you deploy it to the cluster, you discover that there are errors in the data that you're parsing. So in this phase of rapid prototyping, you want to see how your code behaves before you even deploy it on the cluster and get instant feedback. And then you also need help deploying your job. Hadoop client, it's the command line tool. It's very easy to deploy to a cluster that you either have locally or a cluster that is in your colo. But if you want to deploy things that are behind firewalls or behind maybe SOX proxies, then it becomes a little bit hairy. And you also need to manipulate the file system somehow. And while you can still do that with the command line or with other maybe layers on top of VFS, there's a Fuse, for example, for a Fuse file system for Hadoop. It would be nice, or it would be a little bit more convenient if you have a graphical interface that would allow you to do some of these things. You follow the job progress and so on. And the demos that I'll see, I'll show how these tools would work. So the examples that I'm going to talk about today are fairly simplistic. So one of them is the most painful one, which is the word count. And a little bit history of word count. Word count is very useful when you're building indexes in search engines, because you have a corpus of documents and you want to see the frequencies of words in the documents. And you also want to build a language model, because in English language, for example, you could start figuring out what the stop words are. These are the ones that don't impart any value to the text, like articles and conjunctions and so on. And a couple of other simple examples, like sum and max of a series of numbers. Weather precipitation example that is from Tom White's book. And Excite search logs, just for fun. So Excite has search logs that are out in the public as part of the PIG distribution. And for anyone who's worked with search logs before, most of the search logs are cleaned. Unfortunately, Excite search logs that are with the PIG distribution are unclean. And so if you do statistics on the most common queries, you'll discover the things that something like Google Zeitgeist, for example, or Yahoo top search queries end up suppressing. OK. So maybe a quick digress to talk about log files. So web log files are very common right now. They have a very simple format, and they contain a lot of information that unfortunately is ignored by a lot of people. So an Apache web log file has IP addresses, maybe a user requesting a resource, date and time, and object size, and referrers, and user agents. And in aggregate, if you collect all these log files, you could get back a wealth of information. And that wealth of information, you could see how long a user spent on a site by counting, by having JavaScript events that would tell you when they visited the page and when they left the page, and logging these to log files. Or see the most popular queries like a Zeitgeist or top queries, get the geolocation of users, and then start seeing that most of the users maybe come from Asia, so you need to invest in internationalization or translation. And you could go into a little bit more deeper analysis and seeing flows, user flows. Where do users enter the site and where do they exit, and make analysis on how they exit. And luckily, you could do all these things with MapReduce. The code is complex, so I'm not gonna show it now. I'm gonna use maybe the Excite log file instead, and that only contains 3 pieces of information: the timestamp, the user and the query terms. But even using these 3 pieces of information, you could follow users and see what they search for, or you could build something like a dashboard that shows the top queries. Okay. So I'm gonna skip over some of the code and maybe dive into a demo.